Applying rational functions. Sometimes when we do word problems of things that we're studying at the time, there's like one way to do it, right? It's not the same for applying rational functions. So for sure, I'm going to get through problem number 1 and number 2 with you and start number 4 with you. If we have time, we'll do number 3 together, but for sure 1 and 2 and starting of 4. In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. A tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? So what do you think is the most popular wrong answer when people don't show any work or anything and they just say, oh, it should be 7. Okay, that's not the most popular, but that is an answer. You usually see people say 3.5, right? Because they say, well, 4 and 3, half of that, like added up and divided by 2, that's 3.5, right? But if they're working together, shouldn't it take a shorter amount of time than both of them put together? Okay, so let me zoom in just a little bit. So the first tunnel borer is doing one job in 4 hours. The second machine is doing one job in 3 hours, except they are working together, right? They're working together, so we're adding those two, aren't we? Well, what should that equal? Do we know how long it takes for them to do it together? No, so what do we call that? X? But they're doing the same job, right? That one job, they're just doing it together now. So 1 over X. So remember back, what we need to do is find a common denominator and use that denominator to eliminate the denominators, right? We are denominator assassins, right? That's legal. Denominator assassins, the other kind not legal, okay? So looking at this problem, what would the common denominator be? 12x, right? So if I multiply each term by 12x, well, what happens? What happens with the first fraction? Doesn't the 12 and the 4 simplify to what? 3. So I end up with 3x. What happens with the second fraction? The 3 and the 12 simplify to 4, and I end up with 4x. And what happens with the last fraction? The x's simplify. X divided by x is 1. So I just end up with 12. Well, that's a way easier problem than the one with fractions, isn't it? So 3x plus 4x equals 7x. So 7x equals 12. And to solve, divide both sides by 7. X equals what? Yeah, we can absolutely say 12 over 7, but let me ask you something. Does that mean anything to us in this problem? Probably a decimal would mean something more, right? So what do we get if we put in 12 divided by 7 into our calculator? Okay, so why did you stop at 2 decimal places? I'm just curious. It's pretty safe, right? So we're used to rounding to, especially if we're dealing with money. We usually stop at 2. I'm okay with 2, especially because it doesn't say, right? Now, if it said round to the thousandths, we would definitely need to round to 3 decimal places, right? It doesn't say it all, so I'm fine with you saying this. So remember, once we solve the equation, what's left to do in a word problem? Yeah, we answer the question, and we do that by writing a sentence. Okay? So what sentence are we writing here to answer the question that's being asked? The tunnel will be finished That's perfect. Oh, period. Excellent. Look, I even put it. The tunnel will be finished in 1.71 years. Now, something happened earlier that I want to say frightened, but that's a little bit of a weak word. Terrified? That terrified me. Because they said, oh, so 1 year and 71 days. My math heart was broken. You guys know that that's not what it means, right? Okay. 72 days? Okay, no. 1 year and 71% of another year, right? So we could figure that out if we want, how much 71% of another year would be. We could figure out how many days that would be, right? If I asked you to. I did not. I just said, when will it be finished? Is 1.71 years an acceptable answer? Yes.
Once again, pardon this interruption. Students will have English 2, 5th, 6th, 7th, and 8th period. Please report to the cafeteria at this time. Thank you.
Any questions about number 1? Let's look at number 2. Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers an hour more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. So can we just say 1 over 200 plus 1 over 300 equals 1 over x like we did on number 1? No, not even close, right? Because that only talks about the distance that they're driving, right? Well, there's a formula that you need to know for this problem that hopefully you already know. Hopefully you've already seen this formula somewhere before. Please tell me that you have, but be truthful. What does it stand for? Distance equals rate times time, okay? So that's a really good thing for us to know. It also tells us in the first sentence that he drives 300 kilometers in the same time that she drives 200 kilometers. So their times are equal, right? They're the same. So wouldn't it help, you think, if we would take this equation and set it equal to time? Because right now it's set equal to distance, right? How would I set it equal to time instead? So divide it by the rate. So time is actually equal to distance over rate, correct? Well, if their times are equal, shouldn't their distance over rates be equal? If their times are equal, shouldn't their distance over rates be equal? Because they're the same thing, right? Okay, so let's talk about Tobias first real quick. How fast is Tobias driving? Well, he drove 300 kilometers. That's his distance, right? But how fast is he driving? What's his speed or his rate? So 20 kilometers per hour more than Alicia, right? So then what are you calling x? Whose? That's Alicia's speed, right? So if somebody's speed is based on somebody else's, that somebody else's is who we need to call x. Tobias' speed is based on Alicia's speed. Okay? We know Tobias' speed is 20 kilometers more than Alicia's, but if it's 20 kilometers more than Alicia's, then Alicia's is what we need to call x. Because then we can call Tobias' speed 20 plus x. Okay? Everybody okay with that? So we said a minute ago their distance over times should be equal, right? So let's talk about Tobias real quick. What is Tobias' distance? 300 kilometers. And what is his rate? What's his speed? 20 plus x. And what about Alicia? What's her distance? 200. And what is her speed or rate? X. And what did we say? How should these relate to each other? They should be equal because their times are equal. Okay? Guys, if I have two equations set equal to each other, how do I solve that? two fractions set equal to each other. Yeah, cross multiply. If I cross multiply, I get 300x equals 200 times 20 plus x. So 300x equals 4,000 plus 200x. You still with me? Everybody still with me? How do I solve from here? Subtract 200x from both sides. So 100x equals 4,000. Divide both sides by 100. X equals 40. I have solved the equation. What do I do next? Answer the question, right? Answer the question. Question is, find the speed at which Tobias is driving and the speed at which Alicia is driving. And I suppose if you want to be technical, that's not a question, is it? It's a statement. But you know what I'm saying, right? Okay? So, what am I writing as my answer? Tobias is going 60. Wait, how'd you get 60? I got 40. Oh, x is Alicia. Tobias is x plus 20. So 20 kilometers per hour. And Alicia is going 40. Like that? Oh, kilometers per hour. Gotcha. Period. Okay so far? Any questions about 1 or 2? Okay, we need to set up number 4. Okay, so jump down to number 4. One pipe can fill a tank in 6 hours, while another pipe can empty it in 2 hours. If both pipes are open at once, how long will it take to empty the full tank? So you're comparing it then to problem number 1. Does it make sense that it's similar to problem number 1? What's the job that we're talking about? Either filling it or emptying it, right? Okay. So the difference is, are they working together? They're working against each other, right? So who's faster? The pipe filling it or the pipe emptying it? It's faster, right? So should I start with that one then? One job, emptying the pipe, is 2 hours. One job, filling the tank, is 6 hours. And we have to subtract, don't we? Because they are working against each other, we have to subtract this time. So why did we have to start with 1/2? Guys, if we subtract 1/6 minus 1/2, we're going to get a negative number, aren't we? Can't have that, can we? So we have to think about it first and say which one's faster. If they're working against each other, which one's faster? And that's what's got to go first. Okay? Equals what? One over x, absolutely. What's your common denominator? 6x. So if I multiply each fraction by 6x to eliminate the denominator, what happens at the first fraction? The 6 and the 2 simplify to 3. Yeah, 3x, that's correct. The second fraction, just to x. And the third one, get rid of the x's, so gosh, I hope I can do that problem. If I can't, I'm in trouble. X equals 3. And now it will take, I'm stopping. I just wanted to finish writing take. Where did it? Because 3x minus 1x is 2x. Okay? So it will take 3 hours to empty the tank. You okay with that? Any questions about that? Okay? We have time to start number 3. Do you want to start number 3? Okay. Chef Craig can decorate a dozen cupcakes in half the time as Chef Charlotte. Together they can decorate a dozen cupcakes in 8 minutes. How long will it take each chef to decorate a dozen cupcakes alone? Is it similar to one we've done already? Yes, which one? 1, okay. So we need to do a little bit of work though. How long does it take Craig, or how long does it take Charlotte? Craig can decorate the cupcakes in half the time as Charlotte. So we have 2 choices here, don't we? Okay? We can make Craig X or we can make Charlotte X. It really depends on if you want to have to deal with a fraction inside a fraction or not. If I call Charlotte X, what's Craig? Half X. Do you want to deal with a fraction inside of a fraction? So what if I called Craig X? Then what is Charlotte? 2X. Okay? Guys, neither one of those is wrong. One of them just has to have a fraction, right? So what's Craig's fraction then? 1 over x, and Charlotte's is 1 over 2x, and then together 1 over 8. What's the common denominator? Eight x, right? 8x here, 8x here, 8x here. What happens in the first fraction? We simplify to 8. What happens in the second fraction? X's simplify and numbers simplify to 4. What happens in the last fraction? Oh my gosh, that's the easiest one of all, isn't it? X equals what? 12. I'm going to let you figure out the sentence. Go have a great lunch and a great day.